Got to give the people la, get the people what they want. All right, people want to talk about these transformations. So this first part is just a lot of stuff to write down. So why don't you write this down? Transformation of functions, all right? So you got your basic function. We got plus or minus a, plus or minus x minus h, plus k, right? So each of those things have a way that they affect the graph. So this plus or minus right here does an x-axis reflection. Maybe it makes it open upwards or downwards, okay? But it reflects it over the x-axis. The a value is a stretch or a compress. A bigger number is a stretch, a smaller number is a compress. This plus or minus right here is a y-axis reflection. This is not as common. This is not one we're going to use as much, but just so you know, it does happen. This minus h right here is a shifting left or right. But remember, it's like the opposite. So minus h shifts to the right, and plus h shifts to the left. And finally, this k right here shifts the graph up or down. A, H, and K are called parameters. I'm going to be asking you a lot of times, but like, oh, what kind of shift is that? Is that an A, an H, or a K, right? So you're going to need to know that. They're called parameters because they change the behaviors of the parent function. Oh, I forgot one thing. And this up here, like if it was squared or cubed, or maybe it was a square root or something, it gives the parent function its shape. How could I forget that? All right, so let's talk about exploring function transformations. So let's draw this first function, y equals x squared. Looks like this, so you're going to draw that. But now, well, what if we had y equals x squared plus 2? Well, let's see. Well, where is this 2? This 2 is a k, so that shifts it up and down, right? So this 2 is a k shift up. So it takes this and shifts it up 2. 1, 2. Boom, boom. So it takes the same graph and it just shifts it up 2. That is really ugly. It was here at 0. Now it's shifted up 2 because that was a k shift. All right. Let's look at this next one. Oh, no, sorry. Y equals x, right? So the graph of y equals x is just this line. It's just a line. Well, what if I have y equals x minus 3 now? Why don't you pause it and show what you think the line would look like? So cool. Hopefully, you saw this -3, you're like, oh, that's an H shift, and that goes left or right. So you're like, okay, well, I know, and it's like the opposite. So this says -3, so this is going to shift it over 3 in the positive direction. 1, 2, 3. So I'd have a line, and it'd look like this with that H shift. All right, let's take this next one. Let's do y equals x squared. We know what that looks like. It looks just like this. Why don't you go ahead and draw what you think y equals x plus 4 squared would look like? So hopefully you did that and you're like, okay, well, this is another H shift. This is going to move it left or right again, and it's like the opposite. So this says plus 4, so I'm going to actually shift it to the left 4. 1, 2, 3, 4. Here's -4 right here. So my new graph would be right over here because it got shifted. Boom, boom, boom. Let's check out number 4. Y equals the absolute value of x, right? That's this shape right here. Makes that V shape. Well, what do you think it'll look like if I say y equals negative absolute value of x? So hopefully you're looking at that and you're like, okay, well, this is a -1. So the only thing I did was make it negative. And if I look back, the negative in front of the a value is an x-axis reflection. So it's going to make it from opening up to down. So, okay, so this opens up, so I'm going to make it go, and open down. Couple more. Let's do number 5. Oh, actually, you know what? Let me go back. Don't forget. So this negative is an x-axis reflection. Don't forget that. Okay. Let's do this one. Y equals absolute value of x again. All right. And now we have y equals 3 times the absolute value of x. That's an a value, right? We know this is an a value, and this is a stretch. If it's bigger than 1, that means you have a stretch. So like imagine you hold this thing at the bottom and at the top and you stretch it out. So if you stretch it out, it's going to get thinner and longer. So it's getting stretched. So it's going to get thinner. Stretch makes thinner and longer. That's what a stretch does. Stretch is when the a value is greater than 1. Okay? In this case, the a value is 3, so that's bigger than 1, which means it's going to be stretched out. All right, let's do this next one, number 6. 6 says y equals x squared, and we know y equals x squared looks like this right here. Now, we have y equals 1/2 x squared. So again, this is an a value. But now, since it's a fraction, so it's the a value is in between, so it's bigger than 0 and less than 1. In other words, it's a fraction / decimal. That is a compress. It's like you're smashing it down, you're smushing it. A compress makes it, I probably shouldn't write it there. A compress is between 0, makes it shorter and fatter or wider. So if I take this and make it shorter and fatter or wider, it's going to start to look like this. Goes from this, turns into that. Shorter, now it's fatter and wider. Got compressed, got smushed. Okay? Why don't you try to put these transformations together? This is literally the last one. Y equals -1, x plus 2 squared minus 3. So let's see what I know. First, I know it is quadratic. I know this makes me move down 3. And this makes me move, it's the opposite, so it's going to move left 2. And this negative is an x-axis reflection. So let's see. If y equals x squared, looks like this. There's y equals x squared. So I got to go down 3, so 1, 2, 3. Got to go left 2, 1, 2. So there's my new critical point. And I got to reflect on the x-axis, so instead of going up, I'm going to go down. So I'm going to do this. There we go. Y equals negative 1x plus 2 squared minus 3. All right, that's all we're doing. We're going to get all kinds of practice with this, but hopefully that starts to give you an idea of how these different pieces work and how they affect the graph. Mr. Bass, out.